Jmath.
Welcome to part 2 of the grade 11 trig revision that you need to do before you start grade 12. Okay, so we did the first 4 questions in part 1 of the series, so please go check that if you haven't. Otherwise, let's go on with question 5. So the first thing I'm going to do if I see a question like this, I know it's reduction. I'm just going to write the quadrants to make it easier for myself. So I know this is bigger than 180, so this is quadrant 3, that is quadrant 2, and that is quadrant 4. Now my brain knows that I can rewrite this first one as sine 180 plus. Okay, so 180 plus. If the answer should be 210, I need to plus 30 in there. Okay, minus tan. Second quadrant is 180 minus. And if the answer should be 120, I need to write a 60. So make sure your brackets have the same answer as where you started. Okay, I know many people would say it's 180 minus 120, and then I get a 60. On paper, it needs to look like this. So the next one, cos, that is the fourth quadrant, so it's 360 minus, and that's just going to be a 30. Okay, great. So now my reductions will be a lot easier because I have it in the correct format. Now I can see sine in quadrant 3 would just be negative sine 30. There was a minus, and now tan in the second quadrant would be negative, so minus tan 60, and then cos in the fourth is positive, so this is just cos 30. Sine 30 would just be a half, then a minus times a minus gives me a plus, so plus tan 60 would be root 3, and then cos 30 would be root 3 over 2. So now I know root 3 times root 3 is just 3, so I'm just going to shuffle the order and say that's 3 over 2 minus 1 over 2, and the answer is just 2 over 2, also known as 1. Okay, question B. So 410 is way too big, so I'm immediately going to subtract 360, and then it gives me cos 50. Now at the bottom, that sine 40, I can see it links with the 50, so it is actually going to be cofunction. So I can rewrite that as sine 90 minus 50. Remember, the answer to my bracket needs to be the same amount that I started with. So this I can rewrite as cos 50 over cofunction. So this is also cos 50. Answer is just 1. Okay, remember all those fine rules you learned in the first part of grade 11 trig. Make sure they don't catch you out. Okay, let's get to the next one. So question 6 is all about proving identity. So that's the left hand, right hand type of sums. In grade 11, it really wasn't too bad. But yeah, just watch the space. Unfortunately, in grade 12, this gets a bit hectic. But let's make sure your foundation is correct with grade 11. Question A, I need to choose a side. Now, I can't really do much with the right-hand side, so I'm going to say LHS, left-hand side. And with that, I am going to write out the two brackets and FOIL. So I'm just going to FOIL. So sine times sine gives me sine squared theta. Then sine times cos gives me plus sine theta cos theta. And there's another one. So cos times sine also gives me sine theta cos theta. And then cos times cos gives me cos squared theta. Now I'm just going to write the ones with squareds. I'm going to write next to each other. So sine squared theta plus cos squared theta. And then the other two are also like terms. So that's 2 sine theta cos theta. Sine squared plus cos squared, if the angle is the same, would equal to 1. So this is just 1 plus 2 sine theta cos theta, and that is equal to right-hand side. Perfect, identity is done. Question B. So I need to choose a side where I should start. I can't do much with the right-hand side, so I'm going to tell them I'm choosing the left-hand side. Okay, I'm adding fractions. So go back, take your mind back to primary school. If you add fractions, I need to do the LCD. So with this one, I can see the LCD is just going to be both of those denominators, but in brackets. So 1 minus cos theta and 1 plus cos theta. So there was a 1, there was a 1. So now the left-hand one, I need to multiply by the 1 plus cos theta. And the one on the right, I need to multiply with 1 minus cos theta. So if I just multiply the ones into those brackets, I get 1 plus 1 plus cos theta minus cos theta. All over, now I can FOIL those two brackets at the bottom, and that actually gives me 1 minus cos theta plus cos theta, and then minus cos squared theta. So up top, the cos is cancelled out, and there's just a 2. At the bottom, I'm just left with 1 minus cos squared theta. Final answer is then 2 over sine squared theta. So remember your identities. And then I can say this is equal to right-hand side. So that was identities. These two weren't too bad, but go and practice them if you are unsure. The last section we're going to look at is called general solutions. Remember, that was the one where you chose your quadrants, you got your reference angles, and then you did the solution. So for question A, I'm just going to rewrite. So cos 2 theta equals 0.4. Okay, my quadrants. So cos is positive in quadrant 1 and quadrant 4. Remember, I just go for cast. And that's how I choose the quadrant. Now, reference angle, I am going to say this is shift cos 0.4, and my calculator tells me that is going to be 66.42. Okay, so now for the solution to this, I'm going to say, okay, in quadrant 1, now remember, I am just going to take this angle that I started with, and I'm going to write that there. Okay, so 2 theta is equal to, in quadrant 1, it's just the reference angle, so 66.42 plus K360. And then I must, at least once each sum, I need to say K is an element of Z. Okay, I want theta alone, so I'm just going to divide by 2, and I'm going to get 33.21. Remember to also divide the 360, so this is K 180. Perfect, that's my answer for quadrant 1. Now I just need to go to the other quadrant I chose, which was 4. So 2 theta equals 360 minus reference angle, 0.42, plus K 360, and then you can, just for good measure, just write K element of Z. If you feel unsure about this, please go and check the video on general solution where I explain everything in detail. Okay, so once again, I am then just going to type this in my calculator and divide everything by 2, and that would give me 146.79 plus K 180. Great. That was the general solution for that one. A quite easy one, but you need to know the basics and the rules so that they don't catch you out. Some of the grade 11 sums was quite hectic, but this luckily wasn't. Okay, question B. So now I don't only have one sine or one cos, I have two. So when this happens, we need to shuffle things around, and then I get sine on the one side and cos on the other side. The reason for that is, if I divide both sides by cos now, it's going to turn into tan. So I'm going to say divide by cos theta, divide by cos theta. That cancels out, but on the left, it becomes 5 tan theta is equal to minus 14. I want tan theta alone, so this is minus 14 over 5. Now I can do quadrants and reference angles. Now, with tan, it depends on what your teacher said. So if your teacher is old school, she would say tan always only has one quadrant, and you do K180. I'm going to stick to what the textbooks teach this year, and they would say tan gets a 360. So for quadrants, I would then say tan is negative in quadrant 2 and quadrant 4. To get the reference angle, I'm just going to say shift tan of 14 over 5. Now, very important, I never type in the minus if I do shift tan in the trig chapter. Okay, some of you might remember angle of inclination with analytical geometry. Then I can type the minus, but not in trig. Okay, so never type the minus when you shift tan. Okay, so now my calculator tells me this reference angle is going to be 70.35 degrees. So now I can go for the solution. So in quadrant 2, this was theta is equal to 180 minus reference angle, so 70.35, plus K 360, but K is an element of Z. And then my calculator tells me this is just 109.65 plus K 360. Okay, so like I said, if your teacher is old school, she would say that is the answer, plus K 180. Okay, but for those of you who have a modern teacher, she would say you need to do both quadrants for sine, cos, and tan. So the answer for quadrant 4 would be theta equals 360 minus reference angle plus K 360 and K element of Z. So now if I type it in the calculator, that is just 289.65 plus K 360. Okay, that was general solution, but let's look at one more where you need to go one step extra. So we call that the specific solution. Solve for x, so that's just other language for get the general solution. If sine 2x plus 30 is equal to minus 0.2. Okay, first thing I want to do is then to just get the reference angle and the quadrant. So I'm just going to rewrite my question, equals to minus 0.2. So now I know I need to check where sine is negative. And sine is negative if I do the cast in quadrant 3 and 4. So I know my quadrants, I can just jot down. And then my reference angle, I would get if I say shift sine, okay, never type the minus, so 0.2. And then my calculator tells me that is just 11.54 degrees. Okay, so now for quadrant 3, I am going to use what they started me off with. Okay, so always remember that. 2x plus 30 is equal to quadrant 3 is 180 plus reference angle, 11.54, plus K 360, and then K element of Z. Okay, I need to get X alone, so I'm going to move the 30 over in my first step, and then type it in the calculator, and that would just tell me it's 161.54 plus K 360. Now I can divide everything by 2, and my answer for this quadrant is then 80.77 plus K 180. I don't need to write the KEZ again. Okay, so now we can go over to quadrant 4. So for quadrant 4, I again start with the 2x plus 30, but now it's the fourth quadrant, so 360 minus reference angle, 0.54, plus K 360, and I need to remember to add the K element of Z. Okay, I need to get x alone. I'm going to move the 30 over and type the rest in my calculator. So this would then just be 318.46 plus k 360. Divide everything by 2, and the answer is then 159.23 plus k 180. Okay, so normally if they just asked me solve for x or get the general solution, I would stop there. But now this time they have an extra little bit to the question where they say, but 2x was an element of minus 360 So I then need to go a bit further and just type that in my calculator. So I would always advise use your table method on the calculator and then type in the left part as your fx and the right answer for gx. Then we're going to do start at, we can see this thing goes to minus 360. So I'm going to start at like minus 5. And then it does not go past 0. So my end can be 1 or 3. If you're unsure, just always make it minus 5 and plus 5. Step stays 1. Okay. If I type that on my calculator, I can see the following answers for x. So remember, I only write down the answers between minus 360 and 0. The answers would be minus 279.23, minus 200.77, and then minus 99.23, and then minus 20.77. Perfect. That is then the answer to the general solution and the specific solution. Okay, so that was the revision of all the general trig you did in grade 11. It wasn't extensive enough to go and write exam about it now, but now at least you have a foundation to start grade 12 with. So in grade 12, you're going to learn 2 new things, but they're going to apply it to everything from grade 11. So make sure your foundation is correct.
If this video helped you, please like and subscribe.
Jmath.